Thank you so much for joining us today as we do a walkthrough of the fifth grade water filtration activity. My name is Dylan Elizabeth with In4All, and today I'm joined by.
Noose Hissam from Vernier Science Education.
So today we're going to do a walkthrough of the activity.
So one thing that you're going to need to do is before you go to the site, you're going to want to download this presentation from the In4All website and then personalize this first page so that it has stuff about you and your company. This might be a nice little icebreaker here, especially in the days of superheroes. Would you rather be able to breathe underwater, or would you rather be able to fly? I don't know. I've got this Aquaman vibe going on with me, but anyway, so just a nice little thing to try with the students and see what they say. And then let's find out a little bit of their prior knowledge. Like, first off, we take water for granted. So, what do we need water for? Let the students maybe make a couple of suggestions and then see how they match up with what's in the slide, so you can progress the slide and see if they come up with some of this. Maybe the hydro plant may or may not come to mind. But in Oregon, this is a very important use for water. So, all right. So the other thing is, this is sometimes a little bit, not confusing, but maybe a little bit surprising. How much land water is on the earth? Okay. Well, if you look at this, it's pretty surprising that there's an awful lot of water and there's not that much land compared to it. But then, well, how much of that can you actually drink? And once again, I would be curious to ask the students, is it half? Is it 3/4? Is it 1/4? But they may be surprised to find that it's actually quite a small amount of water that's actually potable, that's actually drinkable. And then we're not the only ones that drink the water. Right. So, we've got all these other critters that are going to share the water with us. So something to kind of get the juices flowing. Why is water important? That's what this is all about. So, and then, water gets contaminated. You might have to ask them like something to the effect of what would cause water to get contaminated. Once again, kind of suggest some things that cause water. Maybe it's the toilet, maybe it's washing dishes, whatever. So there's a lot of contaminated water in this world, as we're all aware. One way to filter water is to let the earth do it. Some of the water will filter just as it passes through the earth into the water table. And so that's a natural filtration system. But what we need as a society is we need to be able to filter water on maybe a larger scale and maybe on a more accessible scale. So that's what we're going to do today is we're going to filter some dirty water. And so let's see. We're going to use two factors or two characteristics of water in this case to determine how well we did in making our water more drinkable. And so we're going to look at the pH, which should sound familiar. And we're also going to look at this concept called turbidity. And once again, folks, we're in a chemistry activity here. No eating, drinking, nothing like that should be happening in the room. So first thing is, let's review what we did the last time we were here. This scale should look familiar. The students will get a data sheet and it has the scale on it. And so we might talk about this a little bit to kind of remind what we did the last time. This is a concept that we didn't talk about the last time, turbidity. How cloudy, how hazy does the water look? And this is another factor that we are going to measure it and discuss in the course of this activity. So what you have to do is build a filter, and what's going to happen is the students are going to get a system like this. This cup has holes drilled on the bottom of it. So this is acting as our funnel, but we're going to put filter paper in there to make it reusable. So our goal, of course, is to start with dirty water and end up with clean water. Well, let's see how well we do. There's two ways that we can improve the quality of water. One is to filter it by using different materials, some natural, some not. Another way to improve the quality of water is to chemically change it. So we can add chemicals to it to improve it. We want to kill bacteria. We might want to add chlorine. If we want to do something with our teeth, we might want to add fluorine. In this experiment, we're going to add a washing soda. And so we'll use that to neutralize, if you remember the last activity. So before you get started, everybody needs to start with goggles. And actually, leave it here for a second, Dylan. I want to show a couple of other things. When you go into the classroom, every student is going to get this glass, the solo glass. Every student is going to need to have this glass completely filled up. Okay, so In4All is supplying every group 1 gallon jug. Now, think about the classroom. If the classroom has 20 or 30 students in it, this 1 gallon jug is not going to be enough. So there's a couple of things to think about. If there's a sink handy, that's one option. Another is to bring more of these, right? Any gallon jug will work. Does not need to come with water. When you're in the classroom, you can put water in it. Usually, I mean, you might ask your teacher if water is available, but this is the setup that you're going to need to start with for your students, not this other stuff over here. We'll talk about that in just a minute. But logistically in the classroom, every student is going to need that. The other thing is you're going to need to find these bags. I don't know if the teacher kept them or whether the students kept them, but they're going to need this bag. And primarily what they're going to need in that, this is left over from the acid-base activity, they're going to need the goggles. Okay, they don't want to splash any of this material into their eyes, so they're going to need those goggles. You, as a demonstrator, are going to need this bag of extra materials. And so this has it has everything that the students are using as far as chemistry testing goes, and you will need this, and you'll see in a minute why you will need that.
Yeah, one point I did want to make is that ideally, if you have more than one volunteer running this activity, you can start the presentation and go through those first few slides about why water is important. And while you're doing that, someone can be setting up the water, distributing that to the students. If you're able to get into the classroom ahead of time, that would be ideal. But that's the next best solution, if not.
Yep. So, okay, Dylan, let's move on. All right. So first thing you're going to do is you are going to do a demo. So you're going to need a sample of clean water, okay, and one in the front of the room or wherever you are located. And then what you're going to do is you're going to make these measurements. As far as turbidity goes, it's just a matter of looking at the water and comparing it to that scale. And by the way, 0 is a possibility. Okay, notice it says 10, but 0 could also be possible. I would hazard a guess that this container of water is not a 250. And so what the students would need to do is on their data sheet, they're going to record the readings for the turbidity and the pH. So let's do the pH. In that extra materials kit, you're going to need to take out some pH paper. It's in a little box like this. You're going to need to tear off a bit of the paper and then set it down temporarily onto a paper towel. In your extra materials kit, there are some swabs. Take one, and just like we did the last time, but you're doing this as a demo for the whole class, you're going to just put a little drop of water onto the pH strip, hold it up for the class, and allow the students to look at it and decide what is the pH of nice clean water. And sometimes we call this the control in a science experiment. Ideally, we want this water, which was straight out of the tap, we want our clean water at the end of the activity. Ideally, it would be nice if we could get this. We'll find out if we do or not. But this is the demo that you'll do for the whole class. And so they'll be watching you, and then they will be recording this value. All right, what's next? So now what you need to do, and this is once again something that could be done in advance to save a little time. If there's more than one volunteer, that would be ideal. What you need to do is set up a contamination station. So when the students are going to bring their cup of water that you poured out previously for them, and what you're going to do is put a scoop, or in the case of the shredded paper, a pinch of material into their water. So I'm going to take a scoop of this human impact. This is coffee and citric acid. I'm going to take a small pinch of paper, don't overdo it. And we're going to take a scoop of soil. Every student will also get a folded piece of paper towel that has materials in it. So every student will get a stirrer, they'll get some swabs, and they'll get some pieces of pH test paper. So when they come to the contamination station, the students will walk away with their dirty water and with this piece of folded paper towel. So they will do that. They'll go back to their station, then wait until everybody else is back at the station, and then we'll go on to the next step. Okay, so they will take their pH paper, and it says to tear that into 4 pieces. They are getting 2 pieces in their kit, and so they would just tear each one in half. So they end up with 4 pieces of pH test paper on the paper towel. Then what they need to do is their kit comes with a stir. They'll need to stir that up.
Ooh.
This is usually a good time to make a big deal about how dirty the water is, like Dylan just did.
It's looking turba dirty.
Turbid and dirty, right? So mix that up with the stick. Try to get it as, mixed up as you can. Okay, the stick can go. If you leave it in here, it's probably going to go down far, and they're going to have to touch the water. So my suggestion would be take it out and just lay it on the paper towel. All right. Now turbidity. Look at this. Look at the turbidity scale, either on their paper or on the presentation, and decide. I'm guessing this is a 250 or a 100, and they would record that under contaminated water. pH, same thing. They're going to take a fresh swab, because they're going to have 3 of them, and they're going to go and take a sample of the water and test that. Okay, and then record that value under pH of contaminated water on their data sheet. Okay, so we have this dirty water, looks to me like it's pretty acidic. What are we going to do to clean it up? Okay, what they need to think about is, how are they going to set up their system? Like, what materials might you use? How might you arrange them in your filter? Think about, you've got chunks in there, you've got looks like a bit of acidic material. What do you know about those things? How can you filter those out? So later, after you've done it, we're going to think about improving it. So you need to kind of think ahead. If this doesn't work well the first time, what might we change? So keep those things in mind. Let's move on here. The students, on their data sheet for the first design, they will decide which materials to use. But they will have a choice of charcoal, sand, gravel, rocks. They can use all of them if they want, 1 scoop of each, or they don't have to. Okay, they can use any of those materials that they want. And so in most cases, in my experience, the kids pretty much want to use everything. So let's bring that over here. So you're going to need a materials station. So I have rocks, I have gravel, I have something that looks like sand, and I've also got some charcoal. If anyone has a fish tank, they might recognize charcoal as something that's commonly used in a fish tank. And so these are the 4 items that they can choose from, but the maximum that they can use is 1 scoop of each. So they would bring their data sheet, and the idea would be the volunteer would scoop in whatever they say on their data sheet. So if they say they want 1 scoop of each, then you'll go through. If you have more volunteers, this might go a little bit faster, but you'll put 1 scoop of whatever they ask for into their system. So I'm going to go ahead and do that. Okay, so there is 1 scoop of everything. I might swish it around a little bit to get it mixed up. I will put that funnel in the catch vessel here. Okay, now stir up the contaminated water, because you may find that just in talking, or in time, it's settled out. So stir it up real good. Try to get things evenly distributed. And then what you're going to do is pour half of it out, because we want to have the opportunity to do this a second time. So if you can imagine, I'm back at my workstation as a student. So I'm going to pour half of this through my filtration system. And it's not critical if they pour out too much. You can always make more, but there's always a time factor involved. And if we look at the original and we look at what's filtering, at least in terms of turbidity, things do seem to have improved a little bit. Okay, so let that filter out. And then notice there it says remove and dispose of the coffee filter. In4All has provided a waste kit. So this kit is actually in 2 parts. The plastic bag is for wet stuff, and the bag is for dry things, or drier things would be like the cups and things. So those could be reused in the future. So when it says remove and dispose of the coffee filter, what you're going to do is, once it's done, a volunteer should walk around with the bag and get this coffee filter from each student and just take it out and dump it. If all the water has gone through, it might be easiest just to lift the whole thing out
Right.
and dump it into the waste bag like that. Okay. All right. So now we've got our filtered water and our original water, and let's see if there was any improvement. So now down here, after trial one, what's the turbidity? Well, when we started, that thing was pretty dark. It looked pretty dark. But at this point, the student should look at their filtered water on the turbidity scale and make a judgment, maybe 50, 25, something like that, and record that. And just like we did before, let's check the pH. So let's go ahead and test the first trial here. And so it doesn't need to be drippy, it just needs to be a little bit wet. It looks like, in my case at least, there wasn't too much improvement in the pH. We definitely improved the turbidity, but not the pH.
This is also a great opportunity for you to dispose of the water.
Yeah.
And so you're going to want to check with your teacher ahead of time as to where the best place to do this is. Ideally, in the sink, if there's no materials, particulates in the water. You're also welcome to throw this in the Ziploc bag. May or may not hold up. Noose recommends a 5-gallon bucket.
Yeah, I'm gonna take 2 5-gallon buckets with me. I've been doing this for years. It does facilitate getting this kind of thing done and doesn't contaminate the teacher's sink and that sort of thing. So your call, but yeah, that would be what I would recommend. Take some buckets. Okay, so second try. Now, if you look at this slide, it's very similar to the earlier one, except we are now going to add a chemical treatment to our system. And you might ask the students, why washing soda? And they may or may not remember from the last time that when they did the acid base activity, that they used washing soda and it was a base. And so that's why we're going to add this to our filter system. So what the students might do is exactly the same, or they might change it, right? There's no rule that says that they have to do exactly the same, but just add washing soda. And so there will be spare coffee filters. And so your system, once you've dumped out the water, should look very similar to this. And they just need to start with a fresh coffee filter and then come back to the materials station and pick out whatever they want. It does not have to be the same. So I'm going to change mine. I am going to not use charcoal. I'm going to use sand and rocks and pardon me, those were gravel, and I'll use rocks. But I'm going to leave out the charcoal just because of my need. But everyone should get, because we're testing this chemical treatment, everyone should get a scoop of washing soda. Okay? And this would be another time where you might want to give it a little swish, mix everything up. Okay. And so that's ready. And so now what you want to do is the other half of your water, your contaminated water. So it might be good to swish it around a little bit, get everything floating, or at least everything, evenly distributed. I am noticing that my stir stick is getting a little flimsy because it is wood. You have spares in the kit. So if a student's stir stick is just not functioning very well, you might hand them a spare. Be careful about the extra kit does not have 25 in there. There's just maybe 6 or 8. So you might want to be careful about announcing that you have one for everyone. But let's go through there and let's put that water through. Okay. And so then what the students need to do is the same thing. On the back of their paper is where they have trial 2, where they can write down what materials they need. Of course, everyone's getting washing soda. The reason being that we want to see what effect the chemical titration has. So write everything down, and then just like we did before, we're going to need to take the filter system off, put it over here, and let's look at the turbidity. So make it just, it doesn't look like it's improved that much. I don't know if that's because I took out the charcoal or not, but that looks like it's similar to what we had before. Let's test the pH. We did add a base to this. Our pH was coming out kind of acidic before. You might even ask the students, what's your expectation if you add a base to something that's acidic? So let's find out. I mean, their expectation would be that it might neutralize it. Let's see if that's true. And looks like it's slightly less acidic. You might decide that it's not quite as red as it was before. Okay, you might add a little more washing soda to see if that would affect it. I'm going to put a little more, another scoop in there and give it a swish. So expectation being that I added more base. Let's test that. I have one extra piece of pH paper here, so it'd be kind of amusing to see if my extra scoop of washing soda actually had an effect. Let's find out. You can see it really does.
Oh, yeah.
Okay, but you can see that it actually did
Neutralize.
have an effect on there. So yeah, then they would record what their pH was. And then just a reminder about waste. Liquids can go down the drain. There's nothing in here that would hurt anything other than maybe particles. So you want to make sure there's no rocks or anything. Solids, well, the messy stuff like the filter paper should go in this big bag that In4All is supplying. And then once you've dumped out all the liquids, then all of these cups can be put into the large blue bag so that they can be washed off and reused in the future. So this large bag is for the drier materials. Okay, these can be recapped and brought back if you don't need them. The students get to keep their goggles, so they can put their goggles back in their kit that has 2 test tubes in there left over from the last time, and they get to keep that. Okay, so what happened? Okay, did you understand anything about how humans affect water in our world? I mean, I hope that this activity would help students see that. Was there anything surprising? Did anything happen that you didn't expect to happen? How could you improve your filter? We saw 2 options here. We were using 1 scoop of every material. How could you improve the filter? How could you make it better? Did you learn anything new today? Was this all stuff that you already knew? These are the kinds of questions that you could ask, see what the students say. And then there's a space on their paper where they can reflect and make a few comments about what they saw, what was surprising, how would you improve it the next time. So this last slide gives you a place to put what your group is going to do the next time you come to visit.
We really hope that the final activity of the STEM Connect program is a career connection activity that is relevant to your career, your professional business in this case. We do have a jet car activity that you can utilize. You do need to contact us and communicate that you would like that ahead of time so we can get you those materials. So yeah, if you have any questions about making that last activity and putting that together, please reach out to your program managers. And I think that's it.
Good luck, folks.
Good luck.
Have fun. This is a fun activity and it's messy.
Messy.
Students love.
And fun.